Hello there, this is another look at some linear programming, Year 12 Discrete Maths. Again, this is a part of the further maths course and I'm teaching this on OCR, but this is one of those topics which definitely carries across. Doesn't matter which board you do, OCR, AQA, EdXL. Doesn't matter which board you do, it will basically look the same. So don't be too concerned if you're not doing OCR. So let's highlight just one thing. This is exercise 6b. There's been an exercise 6a. I would recommend very strongly you go and have a look at it because it's where we practice drawing lots of graphs. But today we're going to actually be doing the formulating, the making, the finding out of the equations or inequalities that basically form a lot of the work on linear programming. So let's have a look straight away. So I've identified some aspects that you need to ensure that you complete in order to be able to say you have done this properly. You're going to be given some like a wordy example. It might be about you're making some I don't know, you're making some tables, and when you make these tables you need, I don't know, some drawers, you need the legs, you need perhaps a table top, perhaps some nice little handles on the drawers, and you would have all these different things that you need for the tables, but you'd also have I don't know, some information about how long it takes to make these tables. If you do a particular type of leg, it might take longer than another, and all of these things factor in the cost of them, the time taken to do it. All of these get factored in to decide which is the best ones to make, because presumably you're making these tables to make a profit, and if you're trying to make a profit, you're trying to maximize your profit. So that's what we're going to look at today. So here's an example, and because I had it in my mind, it's about tables. But this is not about quite like the way I did it. This is about, I'm going to make two kinds of tables, two different kinds of tables. This might be one type, and there might be another type in plastic or whatever. Table A, it says, the cost of the materials is £20. Now, all right, so I just need to be a little bit careful. Very often it's best to make a little a table to show all this information clearly. If you're lucky, they'll give you this stuff. So I'm going across it. What's it? That's the cost. So the cost to make table A is £20. What's it say? It takes 10 person hours. So this is then the time, and it takes 10 hours to make that. And when I do it, it's the profit is £15. All right, so I need a third thing over here, profit. And if you don't get given a table, I'd recommend very strongly you make yourself a table. 15. Then there's a table B, and it says table B, the cost of materials is £12. So you can see you get given the same information. It takes 15 person hours to make. All right, so we now know the time is 15. And where the profit when it's sold is £17. I suppose it assumes you sell all of them, but we'll assume that you are able to sell all of your tables that you make. There is a £480 available. All right, so this is where we kind of put some totals in, and I'm going to put it here. I've got £480 available to buy materials, and there are 330 person hours. So this is a maximum of 330. Notice I don't have to use all 330 hours. I don't have to use all £480, but presumably I'll use most of it in order to make a biggest profit possible. The company wishes to maximize profit. Okay, formulate the linear programming problem. So let's first of all just state a couple of variables. I need an x, and x, I'm going to just say it's the number of table A that I make. Okay, and likewise you can quickly realize I'm going to say y is the number of table B that I make. And you have to do a clear definition of variables. It should, for instance, say the number of. It shouldn't say, yes, x equals table A. I've seen exam questions in the past where they dot marks for being a bit loose with your clear definitions of the variables. So what are the constraints? Well, these are the inequalities, and we've got constraints based on cost and time. So if I look at cost first of all, remember I've said that this table A is x and table B is going to be y. So on that basis, my x is the cost For every table, it's £20. So if 2 tables would be £40. 2 tables would be £40. 3 tables would be £60. And if you just use that logic, you quickly realise that the cost for X tables would just be 20 times by the number of tables, X, 20X. And likewise, I can say the cost for the B tables, well, I've got Y of those, it costs £12 each. So that would be 12Y. And notice, whatever cost I come up with, it can't be more than £480. So this is why I said it was an inequality. It's less than or equal to 480. We've also got this second consideration, this second constraint, which is the amount of time we have. We do a similar thing. We kind of go across. I say 10 hours. I've got X table, so that's 10X. The Y would be 15Y, so plus 15Y. And that's got to be less than or equal to how many hours I've got? Well, I've got a maximum of 330, so less than or equal to 330. Now, it might be you think we've done everything, but we've still got this profit at the end. And this is what we call the objective function. The objective is what we're trying to do. So our objective is to maximize our profit. And my profit I'm going to call P. Well, what is P? Well, this is a very similar trick to what we've just done. The profit will be, we get £15 for every one of these tables. So that's 15X plus the 17Y for the table Bs. And this is essentially done now. I've done the 3 things I needed. I set up my variables here. These were my constraints. There were 2 constraints, which are the obvious ones. And I say the obvious ones because I'm actually going to just highlight the fact that I've missed this out here. It's very, very easy to do. Now, the thing I've missed out is X is bigger than or equal to 0. I can't get a negative number of tables that I'm going to make. Now, that might seem obvious, and it is obvious, but it will matter when we draw the graphs for it, and Y is greater or equal to 0. I suppose there is another one. I can't make 0.3 of a table, so I could also say that X and Y are integers. But at this stage, I'm not going to worry too much about that. So that question now is completed. I've got 1, 2, 3, 4 constraints. All of these were constraints. I have an objective function, and I have 2 variables. Let's do another question. A factory is to install 2 types of machine. So this is very similar, I think. Type A and Type B, the number of operators, floor space, and weekly profit. Now, the only difference is that you can see this has been given to me in the table. This is the kind of question I like because I don't have to do so much work. The company wishes to maximize weekly profit. Formulate the problem, giving definitions and stuff. Okay, then. So I've got one less thing to do. Because I've got the table drawn, but I still need the variables. So I'm going to start here. I'm going to write variables. And it's that X equals the number of, what is this we're doing? Oh, it's machine types installed. So I'm going to say machine A that is installed into this factory. And what's Y then? That will obviously be the number of machine B that's installed. Now, I do think this is something which is quite easy to forget to do, and it's probably going to cost you a mark if you don't define your variables properly. But I think I have. Now I want the constraints. So what the constraints going to be? Well, they very kindly drawn us this table. The constraints are about the number of operators we have and the floor space. So the operators, so that's just right. I'm going to write ops. Now, how many operators I've got? Now, this, remember, is my X. This is my Y. And you can see my number of operators. For every A, I get 1. So I think this is just X plus 2Y. Now, how many have I got? I've got 40 maximum, so less than or equal to 40. And my second constraint is about floor space. Floor, I'll just write floor because I'm too lazy. Now, that's 3X then. Now, it might be 3 square meters or something like this that I'll use. So 3X plus 4Y, and I've got, it seems 100 square meters. Let's assume it is square meters in my factory. Okay, so I've got 2 constraints. Don't forget the easy ones. Easy to forget these. X can't be negative. I can't have a negative number of operators, and it can't be a decimal either. I can't have 1.6 people doing this job. Y is got to be bigger than 0. I can't have a negative amount of floor. No, a negative number in machine B. Yes, they're both the same context there. And then I just need my objective function. What is my objective function? This is the bit I'm trying to, well, profit in this case. Not always profit. You'll see some other examples soon where it's different things. So, but this one is, again, I'm going to try and maximize my profit. P equals, and just using the same logic as before, it's P equals 75x plus 120y. I think I've done that question. I've got variables, I've got constraints, and I've got an objective. So this is the kind of thing you're going to practice in the booklet that you've been given. It's just more of the same kind of question. So hopefully you'll find them fairly straightforward. And then, of course, we've got this next part, which is to say, look, we are unlikely to be given just that to do in the exam, although I have seen it. We're much more likely to be given a full question. And a full question is where we actually do the graph work as well. So here's a question for us. Now let's just have a look at it. On the face of it, it looks similar. A company has 2,400 assembly hours. So this must be like the time. So that's almost like the 2,400 is the maximum it's got. I can see already I'm going to call this one X. I'm going to call this one Y. But it's a bit less going on here. So I suppose I've just got to notice these other things. The availability of components means that most 400 of each can be made initially. Oh, right. Now what that is it's an additional constraint. So my constraints here, let's just go through them. I suppose I should. I was going to say I should say what X and Y is, but then I noticed they've done that bit for me. Let X be the number of model A made and Y be the number of model B made. So I don't need variables this time, constraints. I think I've got 3. And the obvious one is the amount of time or hours that I've got to do this. And you can see I'm going to get 3x plus 4y. That's got to be less than or equal to 2,400. Okay, so far so good. Now, what else have I got? Now, I did say I've got 3. Well, the obvious thing is to say you can't have a negative number of models made of these two types of calculators. It is. I didn't even read that. But there's a bit more that says I can't have more than 400, at most 400. So I suppose I've got X has got to be between 0 and 400. And also, I suppose they could be equal. And Y has got to be between 0 and 400 as well. And there you are. There you have it. They are my 3 constraints. Now, I've not finished this question, though, because it does set up, and it says set up this as a linear programming task. So I've done that and find the maximum profit. Now, I find the maximum profit by drawing a graph. So if I just write down those again, I've got 3x plus 4y is less than or equal to 2,400. And if you've watched the previous video, you'll know how to draw that kind of graph. And the other one was that, oh yeah, it was between 0 and 400. So 0 is x is 400. And 0 is y and 400. Now, if they're that kind to you, they'll do what I've done here, and I've drawn you a little graph. Now, it's not to say they will for you. So you might have to draw your own axes, who knows. So normally what I would do here, I'm just conscious that I can't actually. Normally what I'd do is I would say, well, I'm going to draw these inequalities. I'm going to think of this as the line 3x plus 4y equals 2,400. And what I tend to do is I ignore the 3x's and I say 4y equals 2,400. And that would say y equals 600. But you quickly realize that isn't on my graph. I know it crosses up here somewhere, but that doesn't help me particularly. And likewise, the 3x, that, if you think about it, has to be 800 to be 2,400 if I ignore the y. And that means it crosses over here somewhere. But I can't very easily draw this graph. So what I do instead is I put a number in. I'm going to pick a number. I'm going to pick a round number fairly at random. I'm going to say x equals, I don't know, something like 200 sounds reasonable to me. And I'll work out my y. And then I'll do the same thing. I'll say x equals 300. Or x equals 300. And I'll find a y value. So let's let's do that straight away. When x is 200, now I'm going into this, remember, into this. So 3 lots of 200 is 600. That leaves 1800. That's 450. And that just about fits my graph. So right then, so I've got a point straight away. 200, 450 is about there. You can kind of see that. That kind of does agree roughly with my line, which I made up. And when x is 300, that's 900, it leaves 1500. I reckon that's 1500 divided by 4, which is 375. So that was x is 300, and this is 375. So you can already see that straight away it's not the most accurate method in the world, but it does, if I had a nice ruler now, allow me to find, I say if I had a nice ruler, it would allow me to draw a line going roughly like this. And yeah, I'm not saying for one moment that's done properly. Now again, notice I want less than or equal to it. So following our rules from before, we colour above the line. We do the opposite of that. Now normally there'd be more than just one diagonal line, but on this one actually, I've only got these two other constraints, so they're a bit limiting. And what are they? So x is between 0 and 400, so effectively I've got a line going up this here at 0. Again, allowing for my slightly dodgy pen. And there at 400. Oh no, I've done that. I will need it in a bit. But the x line at 400, it goes up there. And again, I want between those two numbers, so I colour in the bit I don't want, I colour on the outside. So more than 400 is coloured, less than 0 is coloured. There. And the reason why I knew that 400 line there was okay is because y had to be between 0 and 400. So I'll draw the 400 line there since I've already started it. I'll draw the line for y equals 0, which is really just the x-axis. I colour in the bits I don't want, so less than 0 I don't want. And you can see more than 400, by the way, is I don't want. So this is my R, and I talked about this being the region that I'm after. Now, given that that's my R, what I do is I identify, and we saw this in exercise 6, I identify the vertices going around here. So these are the vertices I need. So, and what I then do, I will substitute them into my objective function. What was my objective function, by the way? My objective function, is that the right one? There, I got there eventually. My objective function, I don't think I actually wrote down the objective function. No, I didn't. So my objective function is this 7x plus 8y. Okay, so I've got to maximize my p equal to 7x plus 8y. And I went back and found that, but of course I had this table up here again. Okay then, so I'm going to basically use this objective function, and I'm going to take the coordinates of all my vertices going around my region here. And obviously down here is 0, 0. Now if I put 0, 0 into that, P will quickly be discovered to be nothing. If I make no calculators, I make no money. Let's do this point up here. This is 0, 400. Now if I substitute 0 and 400 into that, I think I get 8 4s are. So 3,200, I think, for doing that one. Now the next one which I can do is, well, I've done that one. I can do this one here, and that one. Well, do I know what that coordinate is? That's y is 400. No, I don't think I know that yet. Now, obviously, I could guess. It looks about 260, 270. To work it out exactly, I can say I can go because it's on this line. I can say 3x plus 4y. 4y is 4 times, that's 1600 equals 2400. And so that confirms to me 3x is 800 and the x is 260, well, 267. I can't have decimal numbers of calculators I'm making, so that's going to have to do. So at that point then it's 267, 400. I think I might need to get my calculator out for this one. So this is P equals, and it's obviously 7x plus 8y for the objective function. 7 times the 267 plus 8 times the y, which is 400. That's 5,069. So you can see that one's much, much better than that one. I've still got 2 more points to do. Let's do the easy one first of all. That's 400, 0. And you quickly realize that's not going to be particularly good. P equals 7 times 400 is 2,800, and 8 times y. The y value of 0 is still nothing, so it's done. The last one I've got to do is this point here. Now what is that? Is that the same? That's not quite the same. On this one I'm going to do 3 times, so it's 3 times the x, which is 400, so that's 1200 plus 4y equals 2400. All right, that's a better number, I think. 4y is 1200 and y is 300. Shows you my graph isn't overly accurate here, doesn't it? You can see that miss. You can see I drew this badly. Anyway, so now I've worked out precisely. I know my point is 400, 300. My suspicion is that's going to win this battle of maximizing the p-value. So what is it? 7 times 400, 7 times the 400 plus 8 times the 300. 5,200. Yes, it does just about win. 5,200 then. And so I suppose just to finish this, I'd write P is maximized when x equals 400, y equals 300. And I suppose depending on the kind of question it is, I might need to be a bit more specific about the details of that in terms of the context of the original question. One final thing then, we in class are going to be looking at these booklets, and we have already done some of these questions in this booklet, and we're just going to do some questions to finish them off, and basically that is it. So that's year 12 work for linear programming done on from chapter 6. Got one more to do, which is the chapter on game theory, chapter 7, and then we've completed the year 12 discrete course. Thank you very much.